Hello everyone, welcome to my channel. In the previous video I promised that I was going to look at this question in the next video. So here we are. How do we approach this question here? It's a simple algebra question. It's the square root of x, the square root of x, the power square root of x, power square root of x, and so on, without stopping equals 2. How do we approach it? Well, first we need to understand the meaning of the three dots. Basically the three dots represent a continuous sequence or pattern going without stopping up to post infinity, if you like. So the approach then is as follows. Simple trick that we use here. Let me capture the question. So we have the square root of x to the power square root of x, power square root of x, the power square root of x, power square root of x. Remember, I have added one more here now to show you that you can continue adding. That's basically what the three dots represent. So this is equal to 2. Now here is a trick. Here is a trick. So what we're going to do now is the following. In my next step, I'm going to say this equation is the same as, and I think I must put the equal sign a bit lower there because I'm too close there. As you would imagine, the exponents would continue. Maybe I may end up hitting the 2 there. So in the next step, here is the trick I'm going to use in the next step. I'm going to start from here. Square root of x. So that means square root of x in brackets, watch this, to the power square root of x, power square root of x, power square root of x, and to the power square root of x. If you like, I can actually maintain 4 powers here. Let me maintain 4 because in the question we have 1, 2, 3, 4, 5. Actually, we have 5. So I'll keep it like that. We have 1, 2, 3, 4, 5 x's and the 3 dots, exactly how I've written it here. And so I've introduced brackets there to separate this first one from the 4. And then the 3 dots are saying I can add one more. If I want, I can continue adding. Right, and this is equal to 2. So far what I've done is to simply introduce the brackets. But here is something very nice and beautiful. Look at this, and allow me to use maybe a darker marker here. Look at this one here. Look at this expression and this expression. The question is, are they different? The answer is no, they're exactly the same. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and the 3 dots exactly the same. But what is this whole thing equal to? Is equal to 2. So I can rewrite this then, if you allow me to use darker marker, I can rewrite this to square root of x to the power 2. And what is this equal to? 2. And what is square root of x to the power 2? The answer is just x. And what is this equal to? 2. So this is the final solution to this simple algebra question. Tell me what you think about this. It's kind of funny, but that's exactly what it is. And you can try using your calculator. Put 2 there and keep on raising to the power square root of 2 continuously without stopping, maybe until the calculator says there is no enough memory. Then remove 1 square root of 2 and then press the equal button. You'll see it will come very close to that. It will be actually 1,99999 or exactly 2 sometimes. So that tells you that this is actually gives you an idea of what we call series, so to speak. So the whole of this expression converges to 2, if you like, the idea of convergence, but that's the solution. All right, tell me what you think about this. I will see you in the next one.